What if I told you there was a secret map, a Rosetta Stone, for mathematics itself? An idea so profound it could connect seemingly unrelated worlds of numbers and waves, and even reveal hidden symmetries of the universe. For decades, this was just a dream, a set of wildly ambitious ideas called the Langlands Program. But now, a key piece of this grand puzzle has been solved. Today on G Fun Facts Online, we're diving into the colossal proof of the Geometric Langlands Conjecture, a story of a humble letter, a 30-year quest, and a discovery that's shaking the foundations of both math and physics. Our story begins in 1967, not with a triumphant announcement, but with a cautious letter. A young mathematician named Robert Langlands wrote to the legendary André Weil, outlining a series of speculative connections. He suggested that number theory, the study of whole numbers, was secretly related to harmonic analysis, the math used to break down complex signals like sound waves. Langlands was so unsure, he ended the letter by saying, "If you are willing to read it as pure speculation, I would appreciate that. If not, I am sure you have a wastebasket handy." Luckily, Weil didn't use his wastebasket. That letter sparked a revolution. The Langlands Program proposed a way to translate impossibly hard problems in one field into a different mathematical language where they might be solvable. This very program would later be instrumental in the famous proof of Fermat's last theorem, but proving the original program was incredibly difficult. So, in the 1980s, mathematicians tried a new angle. They created a geometric version of the problem, giving birth to the Geometric Langlands Conjecture. This allowed them to use the powerful tools of geometry. Now, the core idea is incredibly abstract, but think of it like this. You know how a complex musical chord can be broken down into individual notes? Or how any digital signal can be described as a sum of simple sine waves? That's called a Fourier transform. The Geometric Langlands Conjecture does something similar for much more exotic objects. It provides a mathematical recipe, a correspondence, showing that complex data attached to a geometric space can be understood by breaking it down into fundamental building blocks, each with a unique label from a totally different mathematical world. For decades, even this geometric version was considered almost impossibly hard, until May 2024. A team of 9 mathematicians, led by Dennis Gatescory and Sam Raskin, announced they had done it. Their proof is a monumental achievement, spanning over 800 pages and representing more than 30 years of collaborative work. The complexity is mind-boggling. One of the founders of the field, Vladimir Drinfeld, admitted it's almost impossible to explain the result, even to other mathematicians. This isn't just a solution. It's a testament to human persistence, earning Gatescory the prestigious 2025 Breakthrough Prize in Mathematics. So a super hard math problem got solved. Why should you care? Because this changes everything. In mathematics, it validates a unifying vision of the subject, providing a powerful new toolkit that will, as one expert put it, seep through all the barriers between subjects. But the most stunning part might be its connection to physics. Back in 2007, physicists discovered that the math of the Geometric Langlands Conjecture perfectly described a deep physical symmetry called S-duality. This is a wild idea, suggesting a fundamental relationship between electricity and magnetism, and between different theories of quantum physics. With this proof, physicists now have a rigorous mathematical foundation for these ideas, potentially giving them new tools to understand the fundamental forces of nature and string theory. The proof of the Geometric Langlands Conjecture is more than just an answer to a question. It's a masterpiece of 21st century science. It shows the deep, hidden unity of the mathematical world and its surprising connection to the physical universe. The Rosetta Stone for math has been deciphered, and scientists are only just beginning to translate the incredible secrets it holds. It's not an ending, but the beginning of a new chapter in our quest to understand everything. Thanks for listening to G Fun Facts Online.